This is a review of question 4 in exam 1. A cannonball is fired at a mountainside with an initial speed of 50 meters per second at 42 degrees above the horizontal. It's shown in the figure below. It explodes on the mountainside, a horizontal distance of 200 meters away. Part A. How much time passes before the cannonball hits the mountain? Okay, so what's known in this part? Well, we know what the initial velocity is. It's 50 meters per second. And then we know what the launch angle is. It's 42 degrees. So we know what the x component of the initial velocity is just by multiplying these. The initial velocity with the cosine of the launch angle, 42 degrees. And when we do that, we get 37.2. And we can also evaluate the y component of the initial velocity, which is just equal to the initial velocity times the sine, 42 degrees, and that's 33.5 meters per second. We also know what the horizontal distance is. Delta x is equal to 200 meters. And we want to find the time it takes to go from x equal to 0 to x equal to 200. And we have our equation for the motion in the x direction. Delta x is equal to v sub o x times the time interval, delta t. We know what delta x is, and we know what v sub o x is. And this v sub o x never changes. That's its horizontal velocity throughout its motion. So we can go ahead and calculate delta t. Delta t is equal to delta x over v sub o x. That's 200 meters divided by v sub o x, which we know is 37.2 meters per second. Right here, we evaluated it. So when we put that in our calculator, we get 5.4 seconds. In part B, at what vertical height, y sub f, does it hit the mountain? Well, we know our equation 2 is y sub f is equal to v sub 0 y times the time plus 1/2 the acceleration times the time squared. So that's minus 1/2 g, where g is a positive number times the time interval squared, where I'm assuming that the time interval is delta t is equal to t final minus t initial, and t initial is 0, and I'm just calling t final t. So I put in these numbers. That's 33.5 meters per second times the time, which we just calculated, determined in part A, minus 1/2 times 9.8 meters per second squared times the time, 5.4 seconds squared. And we put that in our calculator, and we get to two figures. .38 meters. Okay, then for part C, we're asked to find the magnitude and the direction of the velocity of the cannonball as it hits the mountain. So we want to find V final. And we know what the initial velocity and the y direction is. We've already calculated that. So V final, the y component of V final, is the initial component of the y component of velocity plus acceleration times the time, which is minus gt. So we calculate that, and this is equal to 33.5 meters per second minus 9.8 meters per second squared times the time, 5.4 seconds. And we see that the y component is equal to minus 19.4 meters per second. And we already know what the final, the x component of the final velocity is equal to the x component of the initial velocity, which is 37.2 meters per second. So we solve for V final. V final is equal to the square root of the square of the x component plus the square of the y component. And we find that the magnitude of V final is equal to 42 meters per second. Then, to solve for theta sub s, the final direction, we draw the vectors by the components of the final velocity. So the x component is 37.2, and the y component is about half that, and negative, and it's 19.4 pointing downward. So V final points down in this direction, below the x-axis. Here's theta sub f. The magnitude of theta sub f is equal to the tangent, the arc tangent, the ratio 19.4 to 37.2, and that's 30 degrees. So the angle theta sub f is equal to minus 30 degrees. That is 30 degrees clockwise with respect to the plus x-axis. And that concludes this video.